Alright, for physics question 3 part A, okay, so we are given a 8 kg crate that must be raised from the ground to a truck by sliding it up a 2.5 meter long ramp, okay, and of course incline at 30 degree. The man predicts that he can get the crate onto the truck by giving it an initial speed of 5 meter. Okay, so I give it an initial speed of 5 meter per second, right? So however, it only slides 1.6 meter up the ramp, okay, and stops and then slide back down, right? So 1.6 is around here. All right, so maybe I just draw 1.6 meter. Okay, so you can see for this case we have to consider gravitational potential energy, and of course we need to use a bit of your tuakaso. Okay, so first of all we want to find the average frictional force acting on the crate. Okay, our principle conservation of energy. Okay, so this one tells us that KE1 plus GPE1, okay, equal to KE2 plus GPE2. Okay, of course, plus your work done by friction. Okay, so this is the formula. This is the formula that we must know. Okay, so yeah, right. So first of all, at the start, what I'm interested is the before and after, right? So before is at the bottom, okay, after is at the top right here. Okay, so I'm interested only in these two points, before and after. I'm not interested in what happened in between. Okay, so alright, so let's calculate. Okay, so at the start, at the bottom of the ramp, okay, my GPE1 is equal to 0. Okay, then my KE1, of course, I can calculate. Okay, half times mass, which is 8, times your speed square. Okay, and alright, so as I move up the ramp, okay, and I will travel 1.6 meter. Alright, and I stop, right? Okay, so at the final point, the velocity is 0. Okay, because I must stop before I slide back down, right? So that's why my speed is 0. Okay, so my KE2 will be 0. Okay, for GP2 is where we need to use tuakaso. Okay, because I need to calculate what is the height that is being traveled by my box, right? So okay, so my hypotenuse, okay, so this is a right angle triangle, right? So my hypotenuse is 1.6 meter. Okay, so I'm trying to find my opposite, right? Okay, because this is opposite, this part is opposite, right? So I must use right? Okay, so it's sine, right? So 1.6, okay, so this part, okay, this part is 1.6 sine 30 degree. Okay, yeah, so this will be my height. Alright, so if you calculate, you should get about 0.8 meter. Okay, so about 0.8 meter. Alright, so okay, so my GPE2 is MGH, right? MGNH. Okay, so where M is 8, G is 10, and H is 0.8. Okay, so you can see that if we calculate, we should get about 64. Okay, about 64 joules. Okay, so you can so basically the gravitational potential energy that's gained by my box is 64 joules. And now I calculate what is my initial kinetic energy. Okay, so you can see my initial kinetic energy is bigger than my gravitational potential energy gain, right? Alright, so apparently there is some work done by friction. Okay, and this work done is opposing the motion of the box. Okay, so my work done by friction, okay, is equal to 100 minus away 64. So this one will give me 36 joules. Alright, so okay, so now I know my work done. I can calculate my force. Okay, so normally for this type of question is rather difficult especially for like even for me last time when I was secondary 4. Yeah, I mean I always do not say don't know how to do lah, just always feel a bit struggling in this type of question. Alright, so work done by friction, remember what is work done? Okay, work done, the definition is force times distance, right? Or yeah, or force times displacement, whether depends on the textbook definition. Okay, so work done by friction, the force okay, force times distance the force that we are interested is friction. Okay, frictional force. All right, and you can see when my box light up the friction is acting on this particular surface, right? Okay, so the distance that the frictional acts is 1.6 meter. All right, okay, so it's 1.6. Okay, so this one is force times distance is 1.6 meter. All right, and the work done we have calculated is about 36 joules. Right, so you just get what is your friction. Okay, so 36 divide by 1.6. Right, you should get about 22.5 newton. Okay, so your frictional force that is acting on your ram is about 22.5 newton. All right, so you notice that they use this word average. Okay, average frictional force. Okay, why do they use average? Is because frictional force depends on the speed. If the box is traveling very fast, right, means that the frictional force is bigger. And if the box is traveling very slow, the frictional force is smaller. All right, so the frictional force, the size or the magnitude of the frictional force that's acting on this 8 kg box is not constant. It's not the same. Maybe at this point, at this let's just say at this particular point, right, the frictional force might be higher. Okay, at this particular point, the frictional force might be lower. Okay, because the speed is slowly decreasing, that's why the frictional force will decrease. So the frictional force is not constant. That's why they ask us to find average frictional force. Okay, yeah, so it's about 22.5 newton.